Hello guys, welcome to another episode of Bazaar Talk Show. We are going to do Wolfram language coding, continue from yesterday. Advent of Code 2023, Day 14, Part 2, Take 4. If you are watching this offline, skip around and play at 1.5 speed minimum, because I ramble a lot. If you are here, say hi. Love to see your comments. Okay. So yesterday, let's start coding. So yesterday we Advent of Code 2023 Part 2 is fairly complicated problem. Okay. Now there are people who solve it in just like 10 minutes or so. They, they are these incredible people. They are code competitors. They are programming speed coding, competitors. They focus on speed coding. So, and it's quite amazing. But usually they are not, in general, they are not great general programmers. Anyway, so this is yesterday, and let me talk about, let me show you what we're gonna do today. Okay, so today's talk show, so go back here, so remove these. Okay, so today's talk show, and we're gonna go to yesterday link here, and we're gonna do, let's see, go back to Emacs showing browser. So this is yesterday. So we want yesterday's goal is to write a command, a function, such that the function takes two things. The function takes a function and takes an initial value. And the function will return the periodicity of the given function when it is nested. Okay, so yesterday it's about almost 3 hours we explained. So we have, we discussed mod 5, mod a number by 5, modular arithmetics. This is a function that has a periodicity of 5. Okay. So, give a value 1, it returns a value. Give a value 2, it returns another value. And, after five inputs, it repeats. So the repetition, the cycle is 0, 1, 2, 4, 0, 1, 2, 4, 0, 1, 2, 4. Okay, if you give it a consecutive sequence of integers as input. Now that's a periodicity of a function by definition. But what we want is the periodicity of a function, of nesting a function. So given a function f, you pass in a value and you get the output, then you take the output and pass that output to the function again. You nest the function, so you get a new output. You repeat this process, and if the output repeats, 1, 2, 3, 1, 2, 3, or 3, 4, 2, 3, 4, 2, whatever it repeats, it's a cyclic. So there's the nesting of the function is cyclic. So there's a periodicity. Periodicity is a number of, the cycle, the length of the cycle in the tail of the list of the output. Okay, so that's a periodicity of a nesting function, which is a different concept from the periodicity of a function. Okay, so we kind of discovered or refined into that concept. So that's a periodicity of a nested sequence of a function. Okay. Now, is it possible for a discrete function to have a different nesting period for different initial value? The answer is yes. And yesterday we talked about how it happens often in dynamical systems, and which relates to chaos theory, often known as butterfly effect. Butterfly effect means a function such that given an initial value, it may become periodic. When you nest it, okay, it becomes periodic into some kind of loop. But however, you give this initial value that's very, very close to the previous one, differ by 0.00001. It's like a butterfly flapping the wings somewhere in South America or something. Then after 10 years, the result is very different. So the function, when you nest the function, the behavior is completely different. So that's called butterfly effect. It's kind of part of chaos theory, which is part of the dynamical systems. That's a branch of mathematics. Okay, and yesterday we also talked about hailstone function, which is the Collatz conjecture. Okay, so here we define the Collatz function. If a function that's defined of integers, if the integer is even, then divided by 2. Otherwise, multiply by 3 and plus 1. So you got a value. Then you feed the value back to this function and repeat the process, see what happens. So this hailstone function, or also known as Collatz conjecture, is unsolved. The conjecture is that the function will always arrive at 1, for whatever input. So that's a conjecture that's unsolved right now. So the hailstone function is very interesting. That is an example of nesting a function where supposedly the periodicity is, I think it's 3, because it always comes down to, I believe, 4, 3, 2, 1, something, we looked at yesterday. So hailstone numbers. So that's the things we talked about. So, but ultimately what we want is to write a function that's named named get period. Okay, actually it should be named get nested period. Okay, so let's start to code. Okay, so this function, let's copy it, undo, wait, let's start to code. So yeah, so we copy the function, delete it, show today's talk show, paste it here, and let's pop it out. Let's start to code. So this is from yesterday. So ultimately what we want is we want to find a function, to define a function here, okay? Get period, okay? Actually, you should be named get nesting period. Okay, so let's rename it. Replace get period by get nest period. Okay, replace. So this is the function we want to write. So the function takes a function f, then takes the initial value f evaluated at the initial value, then feed the output back to the function and repeat. So you nest this function, and you want to see if the function is cyclic, periodic. So, and you want to try a max nest number of times, because if it's not periodic, because you may not know, because the function may be periodic, but the periodicity is 1 billion. So you have to run the function nesting it 1 billion times. And even 1 billion times, you can still not be sure that the function is not periodic, because it could be a huge number, gigabillion, then it repeats, but you don't know. So computationally, we have to say, a max nest, so that, we just try this max number of times. What's going on? What? So control, I have sticky keys on window. Okay, so now, yeah. So you give a max period. Okay, cancel this. So far so good. Say hi if you are here. So we are trying to define this function, and yesterday we are very close. Today we're gonna finish it. Okay. Now once we got this function working, then we go back to the original problem of Advent of Code 2023, day 14, part 2. That's kind of a tricky problem. We'll see if it works out. So we need a get nest period of a function. Okay, so but in order to write this function, yesterday we explored that we found out we need a function to such that given a list of items, let me show you here. Okay, where is it? We want to write this function find cyclic tail. So this function take a list, given a list, you want to find out if the tail of the list is repeated. So for example, if 93232, then it will return 32 because the 32 is repeating. If it's 9323211, it will return 1 because that 1 is repeating. So this is a function we want to write, and we have the answer yesterday. And the answer is that. Okay, so this is Wolfram language. So let's start to kind of code and show, Wolfram language. So this is what we have yesterday. So control shrink a little bit. Okay, so we got this function from yesterday, find cyclic tail, and this is how you define. This is a syntax for the documentation of a function, inline function. Typically in Python, in Emacs Lisp, you can all do that. You can have like documentation for a function. And this feature, by the way, is the first time this feature came to a programming language is from Lisp. Okay, that is why they say Lisp language is kind of like the father of many modern programming languages features, including automatic memory management, so-called garbage collection, which the term, the jargon garbage collection, gets the C and C++ and Rust idiots very excited. They love the term garbage collection, but however, they don't like the automatic garbage memory management. Okay, the proper term is automatic memory management, not garbage collection, my ass. So we digressing into the jargons, the terminology of computer science. The terminology is critically important because when you have the terminology, when you have a phrase, a jargon used in sciences, it's a science about the terminology. It's in computer science, it's in mathematics, it's in engineering, it's in astrophysics, it's in cosmology, it's in chemistry, in biology, it's all in sciences. Okay, so and there are consortiums or associations that define the jargon, that determines what is a proper, better jargon. So the judgment of a scientific jargon is actually very critical. It's a big thing. Okay, so I was saying that in computer science we have the term garbage collection, which is a very bad jargon, because when you have a jargon, garbage, you have tons of it in OOP, in functional programming. We know it, like hash table, stack. For example, hash table, should it be better named hash table? Should it be better named association list, which is also a common name for hash table kind of thing? Should it be better named as a dictionary, which is what Python calls it? But they are essentially the same idea. It's a list of key value pairs, either possibly ordered or unordered. But essentially, it's efficient. The idea is an efficient implementation of a key value pair. Okay, so it goes by many names: association list, hash table, or just hash or dictionary. And in the case of Wolfram language, they call it association. Even just dropping the list, they call it association. So the jargon, the jargon hash table. So which is the better name? So that's a question. That's a question about the judging of the jargon, which is fairly important. Okay, so let me do a digression, and let's just go to xali.info and search for jargon. So you can see I have actually quite a lot articles about that, because this is one of my obsession, because I'm interested, because you want a jargon. So what is a good jargon? What are the criteria to judge what is a good jargon and what is a bad jargon? For example, OOP, object-oriented programming. Is it a good jargon? Now remember, we are not judging what the thing, we are not judging, for example, OOP, object-oriented programming. We are not judging whether that is a good thing or not. But the thing about jargon is that we are judging whether that jargon is a good jargon or not. So I have a lot of articles about that. For example, synchronous and asynchronous functions, very, very common if you are a JavaScript programmer. Jargon REPL, Jargon REPL used to be very popular like 10 years ago. Like REPL, Python REPL my ass. It's bad jargon. So here are some examples of a jargon, okay? Jargons of software industry. Jargons and what determines a programming language's popularity. Okay, math jargons explain. Let's open them. Let's open them, and we are digressing. Okay, say hi if you are watching online. If you want to get my attention, if you like to make yourself known to me and my audiences, you want my feedback or interaction. So, for example, in OOP, there's a lot of jargons, classes, methods, objects. So the question to ask in our context is: are these good jargons? Are there other names would convey the idea better? Okay, so classes, methods, objects, and then you have a lot more in OOP. Okay, so the static class. Static variables, instance variables, very common in Java. Then you have constructors and accessors, okay? Then you have access specifier in Java. Then you have inheritance, that's another jargon, also in JavaScript, also in Python, Then you have class hierarchy, okay? Then you have the jargon interface. Then you have the jargon abstract class, abstract methods, which are derived from the jargon class and methods. Okay. Then you have the jargon iterators and enumerators, very popular in OOP crowd. Not just in Java, you will see that in C# as well, and I believe C++. I don't know C++, I don't know C# really. So then you have code reuse. Well, code reuse is not a jargon per se, but it's a popular phrase in the OOP communities. Okay. Then the worst of them all is this polymorphism fuck. Okay, this is a jargon from idiots that misled, confuses the like few generations of programmers. Polymorphism came from some idiots in academia. The history of that term came from some idiots. So that's an example of some of the jargons. Then you have polyfill. Polyfill is a new jargon which started life about 10 years ago from the JavaScript Zoomer idiots. Okay, you got the jargon polyfill. Okay, I'm not going to explain it, but if you code JavaScript or if you are a web dev, then you know what that means. Okay, you can look up polyfill by a scumbag. In this case, the polyfill is specifically, we can trace the history, the origin of that jargon specifically from a guy. Okay, that guy is do I have it? His name mentioned somewhere? No, it seems like that not. But I know, I know who created that jargon. You can look up. It's on Wikipedia. Polyfill. Okay, polyfill, that's a jargon, new from the JavaScript community. But it's also interesting, this polyfill jargon, as far as I know so far, I mean, it's kind of just remained in the JavaScript community. It didn't go out. It just stayed in the JavaScript community. Okay, then you have the jargon Lambda. Lambda, if you are a Lisp coder, if you are a fan of Emacs, Scheme Lisp, Common Lisp, you'll be very well acquainted with the jargon Lambda, extremely popular among the Lispers and also among the functional programmers. Lambda is one of the most idiotic jargon. Okay, now I'm just showing some examples of jargons. Then let me briefly talk about how do you judge a jargon? What criteria make a jargon a good jargon? What makes it bad? Now, again, remember, we are not judging that thing. We are not judging whether the thing is good or bad. We are judging the label for the thing. What are the good labels? What are the bad labels? So then you have the jargon invariant in programming languages. I discovered this only 5 years ago, like in 2017, which is like seven years ago. Invariant. The invariant jargon actually came from mathematics, but I discovered in programming they also have this invariant. Okay, I don't remember exactly what it is now, but okay, let's read it. Okay, I don't know when did it happen, but the term invariant is beginning to pop up in programming language community. So I wrote this in 2017. Invariant in programming language means something assumed to be true. For example, say power n raised to m. It is assumed that n and m are number type. Okay. 3. Programming language invariant. For example, hash table. Access is assumed to be fast constant time for any key. Okay, so invariant. So 4. I first saw this use of invariant is in JavaScript specification. ECMAScript 2015. For example, ECMAScript 2015. So I was reading lots of the JavaScript specifications. So let's open that. Let's see, just for so here's my own copy, local copy of JavaScript specification on xarli.info. So let's see, where is the invariant? Static semantics is valid simple assignment target. Okay. 12.10.3 runtime semantics evaluation. Where is the invariant mentioned? Let's search. I don't know. Okay, so here. Okay, so we found an instance. So what is this? 12.10.3 runtime semantics evaluation. So this section is a specification of how JavaScript evaluation should behave. Okay, so equality expression equality expression equal relational expression. JavaScript spec is very complicated, and a bad one, I would say. Okay, so anyway, here's a mention of invariants. Note 2. The equality operators maintain the following invariants. A not equals to B is equivalent to, okay, A equals B and not, okay, and A equal B is equivalent to B equal A, okay. Okay, they call it invariant. Yeah, so invariant just means like what I described here. It's something assumed to be true. Still a fuzzy definition. But anyway, so this is the first time where I see the invariant jargon mentioned. So 5, practically invariant means something that is implicitly assumed, but now explicit just so it's clear. For example, in language specification context. And number 6, today I saw invariant mentioned in Eric Raymond's Golang versus Rust essay. Okay, so Eric Raymond, I was reading his blog. He also mentioned the word invariant. He's got a blog. This is written, Go versus Rust versus Go, written about 10 years ago. Where's the date? Let's see if I can find the date. I truly despise those programmers who write their blogs but do not clearly indicate when it is written. So this, so they don't have, there it is. ESR, January 2017, Rust versus Go. Okay, good. He has got a date there. So this 2017, which is 7 years ago, Rust versus Go. So this, let me mention this article. So in this article, he basically he likes Go. He do not like Rust, and I share similar opinion. Go language is a great language. Rust is shit. Okay. Now ESR, Eric Raymond, he's a very famous programmer, of course, as you know. He wrote the Bazaar. He's one of the he's one of the founder of open source movement, which is a split off of Richard Stallman's Free Software Foundation. So the open source foundation began life around 1997. Okay, 1997 or 1996. Which is essentially started by Eric Raymond. Now, Eric Raymond wrote a lot of books. He coded a lot Unix. You can, art of Unix programming, the Bazaar versus the Cathedral, which is a very popular book. He wrote several other books, and he's a pompous guy. He's assuming, he's a very pompous guy. And he's a white man, of course, first of all, very pompous guy, and very, he's a conservative also, politically speaking, he's a conservative. And he's also, the nasty part about this guy, he's somewhat of a neocon. So he promote, in his belief about opinion, he believed that USA, our country, should be the cop of the world. We should, in his opinion, we should attack Iraq. Back then the weapon of mass destruction, the war of terror, which we killed 600,000 Iraq people, non-military people. We killed them, because we thought supposedly they have weapons, so-called weapon of mass destruction. But we found none. And this Eric S. Raymond is fully promoting for the Iraq war. Okay, so that's so in my opinion, he's a scumbag. He is also one of the he's a very popular guy. He has done many things. So promoting Iraq war, promoting gun, which I agree today. 20 years ago, I'm not sure. But today, I fully support the idea that Americans in USA, we should have, the right to own a gun as the Constitution. So he's got many opinions. He's also kind of, he's also one of the two also big founder of the open source movement, which is a branch of the Richard Stallman Free Software Foundation. They are enemies. These two camps are enemies at each other. And today, by now 30 years, we can see that the open source movement kind of won. The Free Software Foundation, the Richard Stallman, branch, they are at war, but they can, Richard Stallman kind of became obscure, except in Emacs, he's still, saying things. But the open source won, but open source has mutated out of Eric Raymond's control completely. Open source, the idea, the movement became, took over by the Google, Microsoft, Facebook, Amazon empires. They don't care nothing about your Eric Raymond. And in fact, Eric Raymond became an enemy of the open source. Why? Because the corporations, the USA deep state, they began the social justice movement began. So they promote things like men can get pregnant, men and women are the same thing, the trans men, and women can be lesbian, women, lesbian trans are also lesbian, things like that, promoted by United Nations. United Nations has a giant poster about, this extremely corrupt, corruption of, extremely corrupt things. So Eric's ESR, he founded open source, but his movement took over by the, deep state. And so he became, this huge amount of smearing against this Eric S. Raymond guy. So there's a lot, stories and history. So ESR, so, let's see, he's got, he's one of the most popular blogger. Okay, so this is not even his site. The name, people don't know his abbreviations anymore. This scum ESR official home, this is like a fraud trying to, took over his name. But today, the Zoomers, the Zoomers don't know nothing. The Zoomers got, their brain got washed since they were born. So here, okay, so you cannot even find his homepage by searching ESR. So if you search ESR blog, then there it is. Okay, he's got this quip on his he's got this how shall we say it, maxim, this chant phrase, this slogan for his blog: armed and dangerous. This is Eric S. Raymond. So looks like he's getting old. He's like 70 something. So the last blog is only 2021. Wow. What? Yeah, this is his website. Yeah, so the last one is 2021. He's getting old. So is Richard Stallman, and Richard Stallman got cancer. It came out about 2 years ago. So anyway, ESR, the story of ESR, which is a chapter of computing history, especially a chapter of Unix. Okay, so we digressed a lot. We were talking about polyfill, we were about Lambda, Jargon Lambda, we talked about ESR. Why are we talking about ESR? Because we were talking about invariants, and ESR, one of ESR's blog, Ross vs. Go, have used that jargon. Let's search INVARI. There it is. You see, Ross gets A+1 here because exposed invariants that you can reason about are better than relying on runtime that you cannot read readily ordered in practice. Anyway, so the jargon invariant, which I think is very stupid jargon. I mean, the very concept of invariant, I don't think it's good. Anyway, so a jargon invariant. Then we have, so here's my index of my articles for the jargons I came across and wrote about. So you got OOP jargons, we got list comprehension, which is made popular by Python and Haskell. these List comprehension idiots, extreme idiots, okay? The Haskell idiots, the Haskell people, the Haskell people are extreme idiots. You think they are functional, they are pure functional programming. They must be mathematicians because they but actually 90%, I would say 90% of all the people who promote Haskell are just idiots, like programmer idiots. They know nothing about mathematics, and they kind of champion the, like whenever I say I wrote an article about why the jargon List comprehension is bad, and this Haskell idiot will counter by saying that, but it came from mathematics. Fucking idiots. Why is it bad? Because yes, it is true, the jargon List comprehension came from mathematics, came from set theory, came from the set notation, okay? And that itself is one of the most idiotic thing, the set notation, to create a set, okay? It's the most idiotic thing, one of the most idiotic fact in mathematics, the set notation, for generating for describing, for kind of a math notation, although not purely, kind of describing what a set is. For example, let's say the set of even numbers. So in mathematics, usually you can write, okay, I digressed a lot, so let me just do so. Go where my brain is, okay? So for example, let's do a screenshot and let's start to draw. I want to draw. So you want to snip and sketch, okay? So for example, set of even numbers, okay? So usually you write it like that. X, then vertical bar, then x divided by 2 is 0, okay? Then you say x divided by 2 equals to 0, okay? That is a set notation. Well, there's a specific name for this set. I forgot what exactly is the jargon. Anyway, this is also called List comprehension. How exactly? Anyway, so this is kind of called List comprehension. Okay, you can go check up Wikipedia, List comprehension. Okay, so the jargon list. What I'm trying to get at is that the jargon List comprehension came from this mathematics notation. Okay, the describing a set. So the Haskell idiots and the Python idiots, they are brainless. They don't know the history of mathematics. They don't even know mathematics. But some of them, the elite hackers, like the Unix idiots, or Python priests, they will say, when you see an article, when they see my article criticizing the jargon List comprehension, they will jump out and claim, "Sir, you are so stupid. It came from mathematics, but you love math." That's a List comprehension. Okay. But why is this set notation bad? Because that's another topic. Okay, that is about constructive mathematics. It has to do with the foundation of mathematics or the philosophy of mathematics. Okay, that's a huge topic in mathematics, in particular regarding the foundation of mathematics. What is mathematics? What should it be? What are the approaches we should take regarding mathematics, especially very abstract concepts such as infinity or infinitely small, like calculus. You deal with like something infinitely small. Do they actually exist? Have you ever seen infinity? Then how can you assume that there's just like infinite? Like what does it mean? Isn't mathematics supposed to be very precise? You have never seen infinity. How can you say 1, 2, 3, 4, 5, it just goes to infinity? Oh, it's just infinity. So, but all those are valid questions. So there's a, philosophy of mathematics. So you have to deal with these questions, And among mathematicians, there are different schools. Some mathematicians, first of all of them, you have greatest mathematicians in different schools of philosophy. So some do not even believe infinity actually exists. Well, they believe it might exist, but it's not something you should use to when you do proofs or things like that. So back to my point. So there are different philosophy of mathematics. Okay, so the three top most popular ones are logicism, which is idea that mathematics is just a branch of logic. Okay, you just like logic is a thing. Then all mathematics can be rewritten in terms of just logical statements. Okay, so math is a branch of logic. That's one major branch of philosophy of mathematics, the foundation of mathematics. That's called logicism. And the most well-known proponent of that is Bertrand Russell, which is one of my favorite mathematicians. In fact, Bertrand Russell influenced me a lot, influenced my life, my view of the world, philosophy of the world, logical positivism, for example. You can look up logical positivism. Okay, look up Wikipedia. That's another topic about philosophy. So anyway, Bertrand Russell influenced me a lot, and I usually like Bertrand Russell's philosophy or his point of view about mathematics or about the world of things. For example, about not just math, for example, about Christianity, about religion, about other things. So one huge school of philosophy of mathematics is logicism. And by the way, speaking of logical positivism, one of the representative literature is Alice in Wonderland. Okay, let me just digress in random. So you can find, I have a collection of the literatures that I liked and I have annotated. So including Arabian Nights, the original, translated by Sir Richard Burton, not a Disney thing, okay? Not Disney's, Disney's Arabian Nights 1001 Night is completely a different thing. It's very, so if you want to know what is the nature of Arabian Nights, these are the nature of Arabian Nights, okay? So that's the Arabian Nights. The nature, the character of Arabian Nights. You got these, thoughts and cheating wives and so on, and with beautiful tits and ass. Literally, it's like literally described how the girls, in some case slave girls, have like huge tits and ass. Okay, then you also got these monsters and this genie, this is called a genie. So that's what Disney focused on, this genie. So, and the genie of the Islamic world, it kind of came from that region, Middle East, not just Islam but Persian, or today's Iran. Iran was known as Persia. So Persia, basically Middle East, you have this, that's their folklore. So genie, okay. So that's about Arabian Nights. So why are we talking about that? Because I was talking about, my collection of articles. literature. Okay, let's go back. So Arabian Night, Flatland. So let's go back to Alice in Wonderland. So I was saying that Alice in Wonderland, I have a copy on my website, xali.org. You can, this is one of my favorite literature. I read it like 3 times from cover to cover in 1990s. So in my opinion, this Alice in Wonderland is a representation of the philosophy logical positivism. Okay, if you don't know that philosophy, you need to look up Wikipedia. It's kind of complicated because a lot of philosophy, they are like little details, like exactly why existentialism, or there's quite a few, or idealism or materialism. Hello, Alexandra. So Alice of Wonderland, in my opinion, is a great representation of the philosophy logical positivism, which is this philosophy logical positivism is the foundation of Western society in the past 100 years. Okay, all the sciences, all the massive progress and critical thinking, that's all from logical positivism. Okay, the foundation of Western society in the past 100 years. Okay, but I have not seen any other person express the idea that this Alice in Wonderland actually relates to logical positivism. So anyway, that's, maybe it's just me, but maybe it's been said before, but I'm not aware of it. So back to, so we were talking about ESR. So I was talking about logical positivism, and we were talking about Bertrand Russell. That's because we are back to, because Bertrand Russell is a proponent of logicism, one of the major branch of philosophy in mathematics. Now, what are the others? The other one is formalism. Formalism, which is most represented by Hilbert, one of the greatest, let's say, top 20 mathematicians in the history of the humanity. Okay, one of the greatest mathematician, Hilbert. He's a proponent of the formalism school of philosophy of mathematics. What is formalism? Formalism means that, the idea is that math doesn't mean anything. What does mathematics mean? It's simply a sequence of symbols governed by particular rules, like Wolfram language, or like when you study regular expression, or when you study the grammar, the context dependent grammar or something, when you study parsers, formal language, so in this school of thought, formalism, mathematics is just a sequence of meaningless symbols, but you have certain rules that tells you how to replace this sequence of symbols by another, which is exactly what Wolfram language is. Which is, this technique is called term rewriting. So you just match terms like we are doing here. Match, it matched, then we do replace. Okay, this is one rule. There are other rules, Or in other words, it's string replacement system. So computation become just replacing strings using regular expression or others. Okay, so this is called, in a programming language, is called term rewriting system, which is the heart of the Wolfram language. Okay, that's formalism, another big philosophy of mathematics. Now, the third biggest, I'm not sure about the, okay, so you got logicism, you got formalism, there's another, the other one is called intuitivism, something like that. Okay, I forgot. Let's go to Wikipedia. Philosophy of math. Okay, you'll see the three main branches. Okay, now the Stanford philosophy of mathematics from the Stanford website is not very good. They are too much philosophy. I thought it's good, but after 10 years reading them, I don't think it's good. I mean it's good for but it's I wouldn't say it's the best. Okay, the Stanford Encyclopedia of Philosophy. Why I have that opinion? Why do I not highly value this website? Because this Stanford Encyclopedia of Philosophy, they are oriented towards for philosophers. So what does that mean? So they focus. They are oriented towards like the philosophers of a philosopher. Like they go into esoteric things. Okay, does things exist, or maybe it not exist because anyway, you'll find lambda calculus, you'll find lambda calculus, philosophy of mathematics, formalism, like we talked about, logicism, intuitionism. Okay, that's the word. Then formalism. Okay, that's the three biggest branch of philosophy of mathematics. Classic. Okay, you'll find a lot of actually programming language topics in this Stanford Encyclopedia of Philosophy, but the way they write it is for philosophers. So if you are a mathematician or if you are a computer scientist, when you read their account, it's no good. It's because they have to fit the philosopher's mind, that like the crazy stuff, like Hegel. Hegel is the worst scum grifter. Hegel, you might have heard of name Hegel, especially Hegel. Okay, Hegel, this scumbag. Okay, Hegel, this Hegel guy is the classic grifter. Okay, this Hegel guy, a German philosopher. He sells voodoo. Okay, to those of people who don't know so much, they will think this is very advanced Hegel. You have to spend a lot of time to understand Hegel, but actually he's just a grifter. Okay, this grifter. So, in my opinion, this Stanford Encyclopedia of Philosophy, they are kind of like Hegel, they talk like meta of the meta of the meta, out of the useless. So we digress so much, so all over. So we were talking about philosophy of mathematics. So let's go back to why are we talking about philosophy of mathematics? Because we were talking about let's go back. Lambda, okay, jargon lambda. Okay, let's go back to jargon invariant, jargon list comprehension. We were talking about how did we start to talk about philosophy of mathematics? I forgot. Is anyone listening? Can anyone remind me? Give me a clue, help me out. How did we start to talk about the philosophy of mathematics? Okay, I forgot, and we also haven't covered what is intuitionism, which is very interesting because I have a personal story to tell. Because I used to believe logicism, and I kind of believed formalism, but it turns out this intuitionism is actually the most practical and concrete, and have the most to do with computing, using computers to prove mathematics. Okay, that's how it turns out. Intuitionism, very interesting. Constructive, or in kind of a sub branch of that intuitionism, is called constructivism. Okay, so in this philosophy, anything mathematics that you cannot actually construct it, you cannot actually write it out or build it, is in a sense nonsense. Okay, so infinity, well, that's nonsense. Okay, so that's intuitionism or constructivism. Okay, which is today the foundation of all the theorem provers. The COG, the HOL, COQ, the assistant math provers, COQ, HOL, or Lean, Microsoft LEAN, Lean programming, like proof systems, and IDRIS, these are kind of these are programming languages to do prove theorems. So anyway, they are all kind of based on this constructivism. Okay, this intuitionism. I object. Like 10 years ago, 20 years ago, I object the intuitionism philosophy of mathematics, because they are silly, because they say they say kind of like infinity doesn't exist. The only thing that exists is actually things that you can actually build. And I was like, what the fuck? I mean, you cannot build infinity, but it's a natural concept. Anyway, so it turns out, so it's very interesting, in the history of mathematics and history of proof theory and history of, foundation of mathematics, or history of computation. These philosophies goes through different twists and almost kind of eats its own tail. Like before I was thinking logicism. I'm a proponent of logicism. Everything is just logic. I support Bertrand Russell, because how else possibly could it be? It's just logic. Therefore, because this therefore that, therefore 1 + 1 = 3. It must be logic, because ultimately there's nothing more fundamental than logic. So I believed all mathematics is just logic. Then you look at formalism of the Hilbert, then that makes sense, because, well, yeah, logic, but you cannot like verbally argue about things. Otherwise, you got 10 billion pages, and you cannot like define a single thing. So you need symbols, like especially with computers. Like all the computer programming language is kind of like Lambda calculus. That's formalism, which means formal language. Look up Wikipedia. Okay, that's very interesting. Formal language. Okay, that's a foundation of theoretical computer science. For example, regular expression, that is a formal language. Okay, now a lot of people don't know this, especially the C++, and Rust idiots, and Java idiots. These type of people, like they have no idea. They just know about memory, bit diddling, and stack, and the hash table. These idiots. So if you want to know about theoretical computer science, formal language is like the foundation of it. Okay, and regular expression is a formal language. Lambda calculus is a formal language. Okay, you can try to study it. So formal language is kind of the theory of formalism. Okay, formalism is the school of mathematics, Hilbert's philosophy of mathematics, which says that all math is just meaningless symbols. and you have rules to say, which one transforms into what, and you just do this formula replacement. That's what this formalism is about, formal languages. So that made sense to me, because when you do computers, that's what it is. so it's funny. But what about logic? Well, it's hard to say which one is exactly. So that's the interesting thing about philosophy, like, because when you hear materialism, then you think, oh, that for sure, because everything is just things. Then you hear about idealism, which says, well, they are not actually things, they are just your imagination, because you are just thinking about things. So, you don't know which one exactly is true. That's an interesting thing about philosophy. So anyway, so you hear about logicism, then formalism, but then I hear about the intuitionism. Okay, so let's get the jargon right. Okay, so by the way, the Wikipedia article on the philosophy of mathematics is very corrupt. Okay, so don't read this one, because the social justice warrior scumbags, starting about 5 years ago, about 2018, okay, they started to they started to get onto mathematics, the math departments of university. They begin in the social studies, the race issue, gender study, social study, black African American study. They have those courses starting around 1990s in United States of America. And you have women's studies. Now, in the 90s, begin with women's studies and black people, African American studies. But now the women's studies is banned, because you cannot allow, how can you allow women? Because there's no women. Men and women are the same thing. So you have the trans and queer studies, the fucking scum, by the white men. Okay, this is the phenomenon of white men power struggle with other white men. They created this mess, because the white men, they are fighting them among themselves, doing a power struggle. Then they created this situation. Okay, so the Wikipedia article on the philosophy of mathematics, starting, I would say, around 2018, they started to mutate, because they started to add, like the social justice warriors. They will say, one of the philosophy of mathematics is that it's all just in your head. It's a social construct, just like gender. It's the fault of the white man because of the patriarchy. Let's see if we can find that part. Contemporary philosophy. Okay, wait, this is philosophy of mathematics. Okay, let's go. Let's see, history, blah, 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 contemporary Platonism, okay, artistic, what the fuck is this? This doesn't belong here, okay? This someone, fuckheads, added this artistic shit. It doesn't, it's not, that's the fake news put in by the deep state. Then there's this, what is this, mathematicism. Crap, okay, that shouldn't belong there. Logicism is classic, yes, Bertrand Russell there. Formalism, yes, okay, by Hilbert, this guy, yes, okay. Then the other big one, intuitionism, okay, started by, this guy, Leopold Kronecker, okay, kind of. Then you have structuralism, embodied mind theories, like what never heard of it. Okay, so you started to have fringe, okay, then you got psychologicism, you got, okay, so fictionalism. It is a bunch of crap. Oh, there it is. There comes the social constructivism. It's all white man's fault. That's what this social construct is, constructive. It's open. It's men's fault beyond traditional schools. Okay. Okay. So anyway, so we digressed into the philosophy of mathematics, but can anyone tell me how did we started to talk about that? So we were talking about the jargon lambda in decline, Rust versus Go, and the jargon invariant, the jargon list comprehension. Oh yeah, we were talking about, so we started to talk about the philosophy, the different philosophy of mathematics, because we were talking about list comprehension, because the jargon list comprehension came from this set theory, set notation in classic math notation. List comprehension, that's where it came from. And I started to talk about philosophy of mathematics because this set notation is one of the most idiotic shit in mathematics, according to if you go by the school of intuitionism and formalism. Okay, yeah. Okay, but the Python people, the Haskell people don't know. Okay, they have no idea. They don't know anything about math or history of math. So we were talking about list comprehension. Okay, then so I was talking about these jargons. I was showing you my collection of essays on jargons. Then there's closure. Okay, very big topic, closure. Which the programming language Closure is inspired upon. You have the concept called closure. Then the Lisp, the Lisp programming language on JavaScript, on Java JVM machine, they call it closure with the difference CLOJURE, closure. So you got the jargon currying, which is popular in functional programming. Currying, it came from the mathematician Curry, logician. You got the jargon tail recursion, which is sung by the scheme lispers all the time. You got the jargon asynchronous and synchronous in JavaScript very much. You got the jargon instance, which is in OOP community instance. Like this object is an instance of that class, which is idiotic. Some of these jargons. Let me talk about another interesting aspect about jargon, about these computing jargons. You see, instance is very hard to define mathematically. Now, intuitively, we kind of understand, because instance is just let's show the article. Where did it go? Yeah, instance, you see. So this jargon happens in OOP programming, object-oriented programming. And intuitively, like most of the jargons, we kind of understand it. You can create a class, then you can say, a variable name equals to, a class declaration of the, class is the type of the variable. Then equals to new constructor, so that creates an instance of this class assigned to a variable. You see, intuitively we kind of understand, it just create an object from a given class. Okay, but if you want to define this in a mathematical way without any talking about process or procedure, like define what it is, not how it became. Okay, like that's a major difference between computer science and mathematics. Computer science is about processes, algorithm. You have to, there's a time going, I do this, and therefore that, there's like a process going on. That's the heart of computer science. Mathematics is what it is. Nothing moves. Okay, you just say, given this thing, this is the result, this is the consequences, properties, and so on. So when you want to try to define instance, in a mathematical way, I found it's fairly difficult. It's like you you don't know. So like you don't know exactly what it is. What the fuck is the instance? It's hard to define it in a mathematical way. Okay, so you have instance, you have the code point from Unicode, you have then you have the jargon finite automata in finite state automata, which regular expression came from. Go back. Okay, so you got go back. Okay, anyway, you got all these jargons. So let's go back, and so we already talked for 70 minutes. We didn't we digressed so much. Where are we? We were trying to start to talk about advent of code, writing a function to find the periodicity when a function is nested. Okay, we digressed over. I think maybe we'll start this topic another day then. Let today just be this philosophy of mathematics and computer jargons digression as the topic. So Alexandra says, you were talking about infinity when you diverged about mathematical thinking. Yes. Yes, that infinity is an example of a thing in of a concept in mathematics where the different schools of philosophy of mathematics, they have like quite different takes, and there are big consequences with that. So anyway, Rudolph says, I once almost took a philosophy course. This week we had tons of readings packed with extraordinary claims and complex terminology. Not a single definition I dropped right away. Okay, in my opinion, philosophy was a precursor to science. Today it is useless, and most of it is just laziness, written by people too lazy to earn real science. Yeah. Well, that's interesting because that touches upon what is philosophy itself. So, and I do have opinions on that, because philosophy is one of the things I'm very interested. I have kind of interest similar to my interest in math, in programming, and the other interests are psychology and philosophy, okay, or about brainwashing, such as how does marketing works, how does fad and fashion arise in society, how does brainwashing works. These are all kind of related. This is about social psychology, or how do you persuade people. For example, there's a book about persuasion, like right under here. This is a very popular book, The Psychology of Influence, The Art of Persuasion, something like that, by this Robert Cialdini. Robert Cialdini. Okay, this was very popular book in 1990s. So persuasion, or brainwashing by the CIA, for example. How do you, for example, during Iraq war, or propaganda, how does propaganda work? Very serious, very important thing in World War II. There's a lot of propaganda on all sides. There is how to persuade people, how to brainwash people, propaganda or fashion and fads. How does a fashion arise? For example, for a decade, we have patterns, programming patterns, which is ubiquitous in programming community. Every programmer will mention, oh, this is patterns. You need to do patterns, like patterns was for about 10 years one of the most popular fashion or fad. Or there is agile programming, so how does it arrive? Like often after 10 years they are gone, they are never heard of again. But during your time, every programmer is like, this is the most important thing. So you see, if something is really truly the most important or critically important, you would assume it's gonna last for good. It's last for generations, because unless there's more fundamental concept or theory that that override it. So but that's not usually not the case. When there's a fashion or thought, it dies, in programming as well, especially, but also of course in women's fashion, or for example, then in the thought patterns of Americans. Every 10 years, let's say, you have certain thought that people, for example, today, you probably heard of let's see some patriarchy, for example. Today that idea has kind of went a little bit, because the social justice thing is kind of going away. But let's say 5 years ago, it's over. Safe space, manspreading, safe space, patriarchy. You hear that, like by everyone. Okay, so let's go. So where are we? So we that's it for today. So we were talking. So I was saying that psychology is one of my interests, especially about the thought and fashion and fad and marketing. Marketing is $1 billion business. And especially applicable in America, because America is a you might say capitalism, kind of very practical American capitalism. So you everything is about sales. Go to Starbucks, McDonald's, Starbucks, they represent America in a significant way, actually. So everything you do is about, like Twitter, you got ads on Twitter, you got ads, marketing. Google makes money by ads, by marketing. And if you have a brand, you have to know about brand names. Yeah, Google, Microsoft, Facebook, Apple. All the Apple fans every day is like, touting their latest Apple iPhone, or this got this feature. Every year Apple has a conference, Apple developers conference or whatever, showcasing their things. Then there's Las Vegas, tech show and whatever. So marketing, $1 billion business. So that's critically important in America structure. And for example, social networking, so-called social networking, which are basically websites, Instagram, Twitter, today known as X. Where is my here? Let's go to it. Today known as X. Twitter, Instagram, Reddit, Hacker News. This is social networking website. It became, as the white people say, toxic, you know. You know, how did it begin? Because the Mark Zuckerberg scumbag, starting around 2004, he started Facebook, and he discovered, oh, if you have a thumb up, that's called gamification. You know, a nice word, gamification. So you just create this thumb up on your website, and people will be conditioned. You know, when I write something, I post something, then other people saw it, give me a thumb up, I feel happy. Oh, this guy read my stuff. He gives, you know, I got thumb up. That is the beginning of psychological control, psychological brainwashing your brain by this giant corporation. It begin with Facebook, the thumb up. Then other people saw it, these so-called Silicon Valley entrepreneurs, you know, oh, that works. You know, then you got Twitter, all the websites got got some kind of thumb up or heart or star. So you have to, like, you know, plus, or YouTube, everywhere. You know, that is the beginning of the rotting of the brain of the population, because you stopped actually saying what you want to say. Instead, you started to think about what kind of thing, what kind of style, what post I post so that I get the maximum number of the thumb up. Begin by Mark Zuckerberg, scumbag. Okay, and today's Zoomers, you know, they have no idea what's going on. You know, they were born into this social networking world with all the thumb up and downs, and you know, they don't know what is a genuine opinion, and in fact they don't know how to write. They don't know how to express an opinion anymore. They just know memes, because meme is the best way to get you thumbs up. You know, lots of spread, and you became so-called influencer, and you can make money by putting marketing ads to your posts. Okay, that's it for today. Bye, guys. So we gonna not doing this problem because we digress so much. We digressed for 80 minutes, and this problem still very interesting. We'll continue it. You know, you'll be take 5. Okay, bye, guys.